হ্যালো সবাইকে, ওয়েলকাম ব্যাক টু আওয়ার চ্যানেল। তো আজকের ব্লগটা একটু অন্যরকম, কারণ আজকে হলো আদিত্যর পিএইচডি হওয়ার দিন। হি গট দ্য ডক্টরেট টুডে। আর তাই জন্য আমরা চলে এসেছি আজকে কেইউ লুভেনে। এখন সব জুরি মেম্বার্সরা এন্টার হলেন এবং এরপরেই শুরু হবে ওর পাবলিক ডিফেন্স।
To the public doctoral defense of Aditya Bhattacharya, I declare the session open. Aditya Bhattacharya obtained a Master of Science in Computer Science at the Georgia Institute of Technology in Atlanta, United States. He has submitted a thesis to the Faculty of Engineering Science entitled Beyond Explanations, Designing Interactive Explainable AI Systems for End Users. And this as part of the requirements for the degree of Doctor of Engineering Science PhD. Aditya will now proceed to defend this thesis. Aditya, you're invited to give a presentation of approximately 45 minutes about your work, and following your presentation there will be the time for discussion of your work with the members of the examination board and with the audience. So, Aditya, the floor is yours.
Thank you, sir. Has a black box machine which takes the input, it does some magic inside it, and gives out a nice cup of coffee. Now, if you take this example and compare with how an artificial intelligence system works, so it works kind of in a similar way. It takes in data as the input. It has a model, a black box model, which is nothing but a complex mathematical equation which learns various patterns from the data and gives out some prediction. Now, artificial intelligence, especially in case of real-world applications, we are kind of witnessing it everywhere. There are so many examples around healthcare, finance, retail, various type of applications which we are experiencing, every day, and it will keep on increasing. But the question is, AI is good, but where exactly is the problem? So let me talk about it a little bit. Back in the Paris AI Summit in 2025, the Indian Prime Minister, Mr. Narendra Modi, actually took a very nice example which got the world leaders at that big stage thinking about it. He mentioned that if we ask something like ChatGPT to create an image of a person writing with his left hand, it is most likely that ChatGPT and similar models will try to create an image of a person writing with their right hand instead. So this is a very simple example, but the same go on for various type of reported issues. There have been several cases of AI making mistake, producing biased result, and even creating a lot of challenges for us as human beings. And these are technology that has been produced by some of the big organizations, the big names like the Microsoft, the Google, the Apple, and so on. Now this can also go on to a more critical example. This is one of such examples where we see a car over there. Does anyone know this car, by the way, Waymo? By any chance? Yeah? Did you all get a chance to experience it? No, not yet. Oh, you have? Oh, that's nice. So this is an example of a self-driving car. So this is like a driverless car which kind of uses an AI to navigate from one point to another. Just think about it, like we are kind of not requiring help of a human driver to actually make that navigation. That's where AI has evolved so much. But the real question comes when AI starts making mistake. Like in this case, there has been a car accident where this Waymo car kind of encountered an accident, and then people start questioning. Questions such as who to blame for, or who is really accountable for such a mistake? Why does this happen? Or how can we prevent it? So these type of questions start coming in. And that's where people start really wondering that, why we are getting such a prediction? Or how can I get a different prediction? That's where the field of explainable AI comes in. Explainable AI is a broader research field which kind of comes up with various type of methods to make AI models much more understandable and provide various type of justifications to the outcomes which are generated by AI. Now, when we talk about explainable AI as a research field, it has been there for quite some time, about 7-8 years or so on. And there has been various type of explainable AI methods that have been produced over the years. These are some of the names. I will not go into the details of it, But the main question comes that there are so many methods, but are they really human friendly? Now, the thing is, most of these XAI methods are primarily designed for AI experts. AI experts are folks who have the technical knowledge of working with AI. They use this method to really go into the model, debug how it is working. But then the challenges of understanding AI for a day-to-day use, especially for end users, really come. And the research field has been giving more focus for AI experts when we talk about explainable AI in general, and the real needs of end users who do not have that technical knowledge were a bit ignored for some time. But then, when we talk about human-centered AI in general, the broader field of interactive machine learning comes in. Interactive machine learning is again a broad research field which believes in putting the human right into the center, and it's about creating this collaborative process where humans can iteratively interact with the AI for better user-aligned outcomes. So my doctoral thesis has been on the intersection of explainable AI and interactive machine learning, and that's why we are calling it as interactive explainable AI in general. And it has been focused around building these systems for end users who do not have the technical knowledge of it. So when we go deeper into it, end users can also be divided into subtypes. It can be divided as domain experts and non-experts. Domain experts are the users who have the technical domain knowledge of their application area, like doctors, nurses, lawyers, financial experts, and so on. And then we have non-experts who are not a domain expert, who might not have the domain knowledge, but they use AI in their day-to-day life for various type of operations. So when we talk about their real user needs or user goals, it can also be grouped into various areas. It can be around really understanding the AI system, debugging it, maybe improving it. It can be around generating actionable recommendations or actionable insights of getting to a desired outcome. It can be around calibrating their trust on the AI, or in some cases it could be around control and personalization. So I hope this explains the topic a little bit, but I'll try to go into a little more on the technical depth and talk about the various gaps and opportunities from a research perspective. So why is interactive explainable AI research important? So prior to this, most of the work in explainable AI has been with static explanations, which is like creating some kind of explanations on an existing system, but it's not in an interactive way. So as a result, you might get some reasoning, and it might not be very useful in certain cases. So that's where many researchers have talked about the benefits of blending in interactivity with explainability to make these systems much more understandable, calibrate trust of such end users, or even helping users for some downstream outcomes such as improving the model, debugging it, even auditing it. Another gap that has been mentioned is around the lack of domain knowledge when we are trying to make these models. So if domain knowledge is really not considered while we are making AI systems, it can lead to inaccurate outcome, which means that typically the model can make mistakes in terms of coming up with real world understanding of such systems. Sometimes understanding different data pattern requires that domain knowledge to really create predictions which are accurate. In some cases, there could be issues around biased predictions, various type of bias creating unfair outcomes. And there could be a lot of integration challenges because of which using AI for various high-stake domains like healthcare, like finance, can be a bit worrying for some time. Another kind of problem which has been mentioned, especially in the literature, is around the lack of actionability of some types of explanations. Like in some cases, end users particularly do not perceive some of the existing explanations as actionable because they seek some kind of guidance to improve the system. And instead of knowing how the model is thinking, they would like to know how to use the model better to come up with better or more desired outcomes. So with this, I'll talk about the research questions because for all doctoral research, we kind of have some kind of research questions which we try to address through various experimental studies. In my case, these are some of the ones. The first one is about understanding how interactive explainable AI system can influence end users' understanding of the AI and calibrate their trust in it. Basically to explore the benefits of such enriched explanation over the conventional approaches. The second one is about understanding how domain experts can actually be integrated in the process of refining AI workflows through such systems, basically trying to target the lack of domain knowledge while building these systems. And the third one is about how such systems can support end users in taking some informed actions towards achieving their end goal, and basically explore the actionability part of such interactive explainable AI systems. Now, when we conduct these research studies, we follow a certain methodology. I'm going to talk about the methodology. In my case, I have followed an iterative user-centric methodology, which means that whenever I'm making these systems, I'm putting the user right into the center of the design and the development process, taking their feedback right from the early stages and following an iterative process to improve it. In most of these cases, these are all application-grounded studies, which means that for the various individual studies that I've conducted, real-world applications were made for various domains. Mostly in my case, it has been around healthcare and recruitment, where the end users were involved, and we had conducted multiple research studies to generate research evidence. Now, in my thesis, I have 4 different studies included. I'll talk about these studies in more detail, but from a general overview, the first one was in the domain of healthcare, where we had conducted multiple user studies, which talks about combining different type of explainable AI methods and analyzing the benefits of them. The second one is around the area of conversational explanation. We'll talk about it in more details, but it leverages systems like large language models, very similar to ChatGPT, which I think most of you will be familiar with, and tries to and is in the area of recruitment, which involves studies with active job seekers, especially to understand how they will be using towards improving their hiring prospect. The third one is with domain experts, especially in the domain of healthcare, which means it has been done with doctors and nurses, where we had conducted these user studies to find out how domain experts can actually be included in the process of improving the models or the systems. And the fourth one is around the area of de-biasing, because these AI models can have some type of bias, which we will talk about again in detail, but it has been also done in the domain of healthcare, where we try to analyze how domain experts can be involved in the de-biasing process. Now, I'll talk about the overall evaluation framework, because whenever we are conducting these studies, we also adopt an evaluation framework to actually analyze whether the systems are working as expected or not. Here I have adopted the framework from Ivania sitting right there, which is a multi-dimensional user-centric evaluation framework, which actually considers different aspects of the system. And it's one of the unique ones which really goes into the details of different dimensions of the system and tries to evaluate it from multiple perspectives. Now, going into the details of it, I'm going to talk about the first study now, which has been included as part of the thesis. The first one is on directive explanations. As I mentioned, that it has been done in the area of healthcare, where we involve healthcare experts and we design an explainable AI system which can actually help them to identify or monitor the risk of diabetes onset. So basically, it's like a pre-screening system which healthcare experts can use to identify if patients can have type 2 diabetes. Now, the system includes different type of explanations. I'm going to talk about them in a little more detail. The first one is about a model-centric explanation, which is typically a feature importance explanation. It's about, it goes into the details of what the model is really thinking and tries to give some kind of score for the various signals or various factors which the model is kind of considering for making a prediction. There are again standard methods which are used, but then it has been visualized in different ways. The second one is about data-centric explanation, which means that it goes into the underlying training data, which is used to prepare the model, and then tries to apply various statistical methods to really find out different signals which users can actually understand. The third type of explanation method is an example-based method, what we call it as counterfactual explanation. So basically, counterfactual explanation gives some conditions which can be used to get an alternative outcome. Like in this case, let's say if the loan application of an applicant gets rejected, then such a method can actually give alternate scenarios by which the applicant's application can actually get accepted next time. So using these different methods, we have designed a system which includes this various type of explainable AI methods. So I'm not going into too much details of it, but in general, it included these different explanation methods, combined them in one particular user interface. And then to design it, we actually conducted certain initial exploratory focus group studies with nurses. And then we designed the initial version. But then since we did it in multiple iterations, we again conducted a qualitative evaluation which involved 11 participants with a background in nursing and patient care. We then conducted semi-structured interview, which is like a process in which we try to ask the end users about various aspects of the system. And then we evaluate it through various standard methods like Braun and Clark's thematic analysis to generate certain insights out of it. Similarly, once we had that initial version, we conducted a final mixed methods evaluation, which involved healthcare experts as well as patients. And then we conducted multiple statistical analysis and certain thematic analysis to generate insights out of it. Now, to talk about the key findings, we really found the complementary strength of each of these methods. And then the main finding is that the benefits of combining them really has a good impact on the overall understanding, the trust, and the actionable decision making of the end users. We went into the details of each method, and we even found some of the benefits of the data-centric explanations, which were the most useful for the healthcare experts. And then for the patients, the counterfactual explanations were most useful because they wanted to even identify in what ways they can reduce their risk. Now, this work has been published in ACM IUI back in 2023 and has been presented there as well. The second study, so next we will talk about the second study. So the second study is about interactive explainability using conversational agents. Now the conversational agents is again a key term, but an agent or an agentic system is an autonomous system which uses large language models as the underlying thinking and reasoning unit. So we used similar agents to have a conversational, like a chatbot system, which users can actually use to have some kind of interaction with them. Now this one was done in the area of recruitment domain, where we involved active job seekers who were currently in the process of applying for a job position. Now the key things that we did as part of this study is through our user-centric approach, we designed the entire system, and even like it includes the overall like the back-end multi-agentic architecture, especially the way the system should behave. Since we talk about multi-agent, I'll also introduce the different type of roles which each of these agents played. So we had this system in such a way that it had a moderator agent which takes in the user query, and then it passes to a recruiter agent and a mentor agent. So these are like systems which can actually play a certain role. In our case, it is playing the role of a recruiter and the mentor, and then have an active conversation whenever a user or an active job seeker is asking a question. And based on that, it gives various type of assessment about the job fitness of a particular applicant, and also gives actionable recommendations about what kind of improvements the person can make in their resume so that their hiring prospect gets improved the next time. So the evaluation part was initiated from a two-phase exploratory user study with active job seekers. So it had like basically two phases. The first one was about a think aloud session where we again involved them in identifying different improvements or different requirements which the users have in such a scenario. And then a semi-structured interview process where we try to evaluate various aspects of the system. Now, once we had that initial user requirements, then we tried to take the same feedback, make a better version of the system, and then conducted a qualitative study which involved 20 active job seekers. And then we had one-on-one interviews with all of them, and we gathered qualitative insights about various aspects of the system. So in terms of the key findings, we really found the benefits of such a multi-agentic conversational system, especially in identifying certain improvements which the job seekers can actually make. And we also explored the dark side of such a system, especially in certain situations when these systems do not give a trustworthy or a fair response. How would users really behave? So in most of the cases, we found that the users showed a sense of empathy towards it. So they will not completely disregard or have something negative against the system, but would try to take their feedback with kind of a pinch of salt so that they are aware of the problems which can occur. Now this work is submitted to ACM-Chi 2026, and the next study that we will talk about is about explanatory model steering. So this is a work in which we involve healthcare expert in the process of refining machine learning models. So we made a system which again provided different type of explanations, and then we involved them in model steering, which means it's a concept in which their feedback can be taken to improve the current version of the model. So we made the, we kind of gave this system where the healthcare experts had the opportunity to identify the feature variables which are really important for making a prediction, or even in some cases if the data had some issues, some kind of problematic data points which are not really good for the model to have, they had the direct control towards refining the underlying training data. And once it has been done, they can retrain the system, save it, and kind of make improvements on top of it. So this system was evaluated using 2 user studies. It started with a quantitative user study with 70 healthcare experts. We conducted multiple statistical analysis on finding different aspects of the system. Especially, we wanted to understand if they were really able to improve the overall model performance. We also wanted to check their overall workload of whether using such a system had any kind of negative impacts or not. And then we also tried to see what kind of changes which they were making into the system. So then we conducted a qualitative study. We even go into the details of it. So the quantitative study helps us, helped us to get some initial high-level insights, but we also wanted to study in more depth, and that's where we conducted a qualitative study with 30 healthcare experts. Now, in terms of the evaluation, we did find key benefits of the data-centric explanation, especially in helping users to understand the system after the steering process. Like once they made the changes, the data-centric explanations actually help them to understand why the system performance improved or did not improve in some cases. But then we also found the limitations of such model-centric explanation, especially some of the factors which the methods highlighted as important. The healthcare experts kind of doubted that. They did not think them to be really important. Whether in fact, they said that the other factors were more impactful in terms of giving the prediction insights. So that's where the insufficiency of such model-centric explanations were actually highlighted. But at the end, one thing we found that a hybrid combination of both data-centric and model-centric explanations were the most useful in terms of improving the overall system performance. The next study that we did was around the area of representation bias. So representation bias is a kind of bias which occurs in AI systems, especially when there are underrepresented data segments, which means that this is an example that we see over here. There are certain groups of information that we see. The number of samples for them in the training data are extremely low. And these are certain segments where the AI model can actually make more mistakes, which means that in this case, if I am making a diabetes prediction model, then the model is expected to perform poorly for maybe underweight or even healthy patients, and especially if they are senior patients over here. So it talks about these various underrepresented data segments where the model actually performs poorly. And in fact, the example that I had taken before about the ChatGPT, creating an image of a person writing with his left hand when asked for an image of a person writing with his left hand or right hand instead. So this kind of mistake basically happens when the training data doesn't have sufficient representation of the expected outcome. Now, in order to solve these issues, most of the researchers have applied a method called as data augmentation. It is a method of creating new data samples. It's more like creating new synthetic samples using certain statistical and approximation approaches. Now these methods, in most cases, they can actually increase the size of the training sample, but it has been found that the quality of the generated sample is not always the best. And that's where even a method such as data augmentation cannot really resolve the problems which can happen due to representation bias. That's where our study comes in, where we kind of had this idea of involving domain experts controlling the overall data augmentation process, where we involved them right in the initial stage of design and development. And we made a system which actually gives them the control to identify the certain data segments which are really important for the model, but has very few samples of the data. And using this system, we allowed them to steer or control the overall augmentation process. Now we evaluated, or rather we started developing or designing this system from an exploratory user study with 5 healthcare experts. We conducted certain co-design sessions, which means the users were involved in the initial design generation process. So once they were able to initially come up with certain designs, we then went in multiple iterations to further improve it. So we collected the initial user requirements and the improved UI designs from this particular study. But then we developed the system where they can actually use it for for a real practical use case. And then we conducted a mixed methods evaluation process where 35 healthcare experts were involved in this process of creating augmented data using their feedback and then trying to see whether it really improves the overall model performance or not. So in terms of the key finding, we did find that domain experts were effectively able to contribute towards mitigating representation bias, and they actually improved the model performance. So they did not compromise the overall model's performance. This is always a debate that giving them control directly, can it actually make the model performance go worse? But we found that they were able to make the model performance much better and in fact mitigate or rather reduce the amount of representation bias as well. Especially in certain cases where they were extremely low represented data, their involvement was much more important because they were able to validate the synthetic data that were created in those cases, and they were able to make massive improvements in the system by improving the quality of the generated data in such cases. And moreover, we found that their overall perceived trust were also increased when we were able to successfully involve them in this process. Now let us go back to the research questions. Let us try to address the research questions that we had by compiling the findings from the individual studies. So especially in the first one, where we wanted to analyze or understand the influence of such interactive explainable AI system on users' understanding of AI and fostering their trust in their output. So one thing we found that by blending interactivity in such explainable AI methods, we did find positive impacts because we were able to see improved trust as well as understanding from the users. And then we found that in certain cases, when we provided the data-centric explanations, especially when the users were able to interact with them by conducting various type of what-if analysis, or rather like making changes in the input and then checking how the overall output gets modified. So they were able to get a better understanding of the system from such an approach. And then we also found that through their interactions, they were able to validate the limitations of such prediction models, identify different potential biases or AI errors, which is actually important in case of forming something called as warranted trust, which means that trust with caution, in simple words, among the end users. About the second question about analyzing whether domain experts can contribute towards refining such AI, AI workflows using interactive explainable AI system. As we discussed before, that we did find positive evidence of improvement of the overall AI model's performance by involving domain experts in such a workflow, especially in identifying certain areas where the data points are misleading, where the features are maybe sometimes corrupted because of data quality issues, and especially in terms of the devising strategies, we found that their involvement is were the most useful in such cases. And using their involvement, we were not able to make the system accurate, like not only make the system accurate, but also trustworthy and allows a key finding as part of our studies. Now the third one was about analyzing if end users were able to improve their informed actions basically for achieving their end goals. So we did find that these systems help them to take informed actions, especially like when we gave them what-if explorations, or even we had certain conversational agents where users were able to have a proper conversation with, and even produce the context-aware counterfactuals, which means that it takes care of the contextual information to give those alternative scenarios by which they can, the users can reach their desired outcome. We found that these techniques were the most useful in terms of coming up with actionable outcome. And the overall, with these different techniques, we were able to align the generated AI outcome with the actual end goals which the user, desires. And that kind of enhances the overall usefulness as well as the relevance of such AI systems. But in case of a PhD, we also kind of reflect critically, talking about certain challenges and the limitations that we have. So these are some of the the challenges and limitations which I would like to call out over here. Now, first of all, throughout these studies, although I focus mostly on the healthcare and the recruitment domain, going into the depth of it, but sometimes some of these findings can be much broader and more impactful if we are able to conduct these studies for various applications. So exploring diverse application domain is something that can definitely benefit a lot from the studies that we have done. The other thing that I mentioned is the standardization of the evaluation measures. I strongly feel that the evaluation framework is extremely comprehensive, but there is still a lot of work that can be done for standardizing the individual metrics which are used for evaluating it, especially if we want to compare different systems. In these cases, the standardization can actually be really useful. The next thing that we will talk about is a problem about the disagreement problem in explainable AI system. Now, one thing that I mentioned in one of the studies that when we combine different type of explainable AI methods, we found the benefits. But in some cases, some of these explainable AI methods might not agree with each other, which means they can give contradictory explanations, which can sometimes be confusing for end users. So this kind of problem is actually called as the disagreement problem in explainable AI. Although I did not find them in the studies that I have conducted, but it's always a risk for other application domains or other application areas. So this is an area which needs to be, researched, I would say, in more depth, so that we can identify the various reasons why such a problem can occur and potential mitigation strategies which can be taken care of. Now, I talked about the benefits of involving domain experts, but to be honest, there are several practical constraints of it. Because the main problem is the availability of the domain experts. In more technical domains, getting domain experts can actually be really difficult. They are already overwhelmed with their daily work, and sometimes getting their time can be very difficult, especially when we are talking about a user-centric approach where their feedback is really important in the early stages of design and development. So that's where there are several practical constraints. In terms of the potential solutions, maybe it requires the broader community to come together and even take help of various type of regulatory frameworks to make the process much more seamless, so that their feedback can actually be taken right from the initial stages and come up with a system which is much more better aligned to the real world outcomes. Now, there are several challenges in application grounded user studies as well. Especially when we talk about user studies, then including or recruiting users is always a key challenge, especially in certain cases which requires much more longer studies, which we often call it as longitudinal studies, which happen in multiple phases. So involving users in such cases can be really challenging. The only solution is to probably come up with a better approach towards recruiting them maybe and working more closely with certain organizations which will benefit a lot from these systems, so that the users from them can be leveraged right from the initial stages of such design and development. But it's not just about the research outcomes. There are various open questions that can even come out of it. Addressing each of these research questions can be an individual PhD of its own, which was unfortunately out of scope for my own PhD. But yeah, these are certain questions which can definitely help the future researchers to shape this overall field of interactive explainable AI. The first one is about creating domain consistent explanation, especially like when we conducted the representation debiasing study. One of the questions that we received initially, that can we automate the process instead of involving domain experts right from the beginning and giving their feedback. Can we somehow gather their feedback and have an automated way of improving or mitigating such bias? So there are definite opportunities, but it needs to be explored in more depth. Then in terms of embedding their domain knowledge right at the beginning, so how can we really come up with maybe a knowledge graph kind of a setup where different kind of information on knowledge can actually be mapped in a much more robust way and use that for creating much better explanations which are aware of the various contextual situations. Then we talked about involving users and through their interactions making systems better. But there is always a potential of user interaction biases, because there is again a group of researchers who are more concerned about the bias which the users introduce to such systems, which we often talk about as user interaction biases. So in our cases, we did not observe such problems because of user interaction biases, but there could be potential situations in which user interaction bias can be a big problem, and there could be potential adverse effects of it. So I believe that is again an area which requires further investigation, so that we know that these are certain situations in which maybe interaction might not be the best way to go for. And then we talked about the need for standardized measurement tools. And I would say especially in the era of generative AI now we are using AI models for various type of use cases. We are not just restricted towards one specific type of task. Although there are certain benefits of it, but there are again certain adverse effects of it. So coming up with maybe better interactive explanations, especially for generative AI systems, can be an active area of research which requires maybe further more in-depth studies to really come up with better strategies towards using them. So these are some of the open questions, but I would like to reflect on some of the contributions and impact that I was able to make throughout the studies and the PhD journey so far. So in terms of the research contributions, I like this framework from Jacob Webrocks on the research contributions in HCI, which kind of groups the overall contributions in separate segments. The first one is about empirical contributions, which means that throughout these research studies, we were able to generate empirical insights, which talks about various type of complementary benefits and even the limitations of diverse explainable AI methods. It talks about the importance of conversational agents, then the importance of domain expert involvement, especially in steering or refining such AI models, and even in case of debiasing, when we talked about representation debiasing. In terms of the artifact contributions, so throughout these studies and research, methods, we kind of developed systems which were interactive, which users can actually use. So we are kind of calling this as artifact contributions. So we were able to make systems for various type of use cases. We designed them using a user-centric approach. So the design, the source code of the systems were made available as well as part of the studies. And then we had some methodological contributions. So we conducted these different user-centric evaluation strategies, especially for interactive explainable AI system. And in some cases, especially in more, I would say, upcoming cases where users recruited from crowdsourcing platform can actually cheat such studies that we conduct with the help of generative AI. So we also kind of came up with certain validation strategies, which helps us to validate the data that we are generating through these studies. And then about the theoretical contributions. So in all of these studies, we came up with various guidelines, various suggestions which can help us to develop similar systems, even for different use cases, which are not just restricted to the application domain that we have used for. So in general, I was fortunate enough to make some publications and able to make some research impact in terms of the citations, which I tried to call out. But apart from that, I got the opportunity to present many workshops, seminars, even research visits, which I'm quite grateful for. And through all these collaborative efforts, I was able to kind of create a little bit bigger impact than only through the publications. So that's about my presentation, and I would be happy to hear any questions.
Aditya, thank you for picturing the story of your PhD thesis and informing us about the outcome and impact of your work. Now we go to the second part of the defense, which is the question answer. We see Professor Torkaman. We can see you now. Hello. I'm going to, while you take a breath, maybe a sip of water, I'm going to introduce the members of the examination board. and they will ask their questions in the same order as I will introduce them. First of all, we have Professor Bhattacharya. She's from the TU Delft, Technical University of Delft in the Netherlands, and in the area of artificial intelligence for health systems. She's here at the bottom left. She will start the discussion, and then all the other members are present physically. Then the floor is for Professor C. Moes from TU Leuven, Department of Computer Science here, followed by Professor Kille de Laat. She's affiliated with the tutorial services of the Faculty of Engineering Science. And then we have our guest is Professor Simone Stumpf. She's a co-supervisor, and she's from the School of Computing Science at the University of Glasgow, Scotland. And then finally, we have Professor Katrien Verbert, who is the corresponding supervisor from TU Leuven Department of Computer Science. Then there's one member of the Board of Examiners that I have to excuse. That's Professor Adalberto Signoni, also from the Department of Computer Science, who couldn't be here today, but he was present at the preliminary defense. And finally, there is me. My name is Joris de Schutter. I'm not a domain expert. I'm from the Department of Mechanical Engineering. I'm just representing the Faculty of Engineering Science at the chair of this committee. Let's call it the Master of Ceremony. So, Professor Torkaman, you have the floor.
Thank you very much for the introduction, and thank you very much, Aditya, for sharing your dissertation and scientific vision and work with us. I truly enjoyed your work and found it captivating. You chose to work on an interdisciplinary topic that is not only novel, but also complex and challenging, with great potential for both theory and practice. That choice and the work that you've done clearly reflects courage, vision, and skill. I would like to start with a question about the many years that you worked on this topic. You have worked on this topic deeply for many years, and I wonder, in your own word, how your understanding and also the field's understanding on the problems and its challenges do you think has evolved?
Okay, thank you so much for the question. It's a very interesting question. I would say that the way it started, it was it was more focused towards understanding only the system and the prediction results. But now it is much beyond that, and that's where I even tried to explore some of the insights around it. It's not just restricted to the AI model that is the central part of such systems, but also how people really use it. And especially in nowadays, when we talk about using AI for such a diverse set of use cases, even the AI models are not designed only for a specific task. When we talk about, especially when we talk about generative AI methods, generative AI methods are not just focused on one task or one domain. They can be used for various tasks or various domains. And that's where it gets more challenging. That's where it's not just restricted to how the system will think something is important or something not important, but also how users will really use in various situations or for various tasks or activity which they are kind of intending to use it. So that's where I think it's more challenging. That's where it needs to be multi-dimensional. It's not restricted towards one dimension. There could be issues or problems that can occur at various levels. It can occur at the underlying data itself. It can happen with the choice of the algorithms. It can happen with maybe any technical part towards implementing it. So that's where I would say that it's more multi-dimensional aspect. In terms of evaluation, I think it becomes challenging, and that's where the multi-dimensional evaluation frameworks was really helpful, because I found it to include different objective aspects of the system, different subjective aspects of the system, different ways which user will really interact with it. Even it includes the situational as well as the personal characteristics of the users, which are actually important in terms of making these systems much more aligned to their real needs. So I would say it's much broader now, it's more challenging now, and the more we will see an evolution in terms of the AI models itself, I would say it will become more critical, and that's where putting the users right into the center of the design and development process would probably be the way to go forward with it.
Thank you very much. A very nice reflection. I want to go a little bit into deeper questions related to the domains that you worked on. Many of your motivating examples came from high-stake domains. Why did you focus on healthcare and recruitment? And given that these domains are relatively very structured domains, what are your thoughts on the applicability of your design principles and findings and their potential for transfer to some unstructured, high volume or adversarial domain, such as social media moderation, cybersecurity, or generative AI systems in general? What would break? What would work, do you think, and why?
Okay, that's again a very interesting question. I think the reason why high-stake domain was important because that's where the main challenges of AI adoption comes in. Especially in high-stake domains where various users have seen the benefit of using AI for various type of tasks. But then there is a lot of skepticism as well. There is a lot of resistance, especially from maybe domain experts, especially in situations where the AI can make mistakes. And that's where the real importance of explanation and even interactivity comes in, which kind of tries to make such systems more transparent. And that's probably one of the main reasons I was more interested towards healthcare and recruitment. But in terms of the findings, I would say a lot of it can definitely be transferred to other, I would say comparatively low-stake domains. Even the design principles are, I would say, can be transferred easily, especially when we are talking about social media. There are multiple situations in which users even may not know the adverse effects of such models, especially the underlying data that has been trained. Even like there are certain situations in which bias in social media algorithms have created a lot of social unrest. And that's where even a small thing can lead to bigger problems. And I believe those are the situations in which explainable AI as well as interactive machine learning is important, which really gives a lot of transparency on the underlying data that has been used. And it even presents certain situations in which such models or such techniques should not be used. I think to me that's actually important because there are such techniques might not be useful for every possible use case, but there are certain situations in which their usefulness would be much higher, and there could be certain situations in which they should not be relied on or maybe over relied on, to be more specific. So I would say such methods makes it much more transparent. And it gives a lot of visibility into the underlying data, and if there are certain limitations or potential drawbacks, it makes it more transparent. And I believe that is the key for making the findings even broader applicable for various domains.
Thank you, very well said. So if you were to start this research all over again, of course no one wants to repeat their entire PhD, but where would you start and what would you do differently?
Okay, that's again a very good question. So let me think. If I have to redo something similar, I would try to go into the depth of systems which are probably more complicated. So it's not just about the application domain, but going into the depth of models which by their nature are more complicated. Like it could be deep neural networks such as DenseNet, or even the more modern transformer networks which are the base of such generative AI models. So I would try to even go into the depth of it and try to identify certain situations from an end user's perspective. Because in most of my studies, I might not have relied on the more modern generative AI methods. And that's where I think there is more requirement in terms of understanding them in more depth. And especially finding those adverse effects or adverse scenarios in which these models should be complemented with maybe even simpler models which can improve on the overall outcome of it. So yeah, that's one thing I would definitely try to do.
Thanks, that would be indeed very interesting. So one other question I had was, where do you see the most unique characteristics of your work compared to prior approaches in the community? And how do you think your work advanced the methodologies and the essence of the state of the art in explainable AI and interactive machine learning?
Okay, I think like the main I would say the finding was in terms of combining explainability with interactivity. There are several explainable AI methods which have a lot of potential, and I personally think their potential is not realized at that scale until and unless interactivity is introduced into it. And that's where the benefits or even sometimes the drawbacks becomes much more visible. And that is something I would say it came out of my work as well. The main benefits of integrating explainability with interactivity, especially for real-world applications. Like for example, even in the representation debiasing case, there are certain situations in which we did not find statistically significant issues in the underlying data. But then when we involved the domain experts right from the initial stages of design and development, we found that in certain cases the data did not align with real-world situations. In real-world situations, maybe there are certain correlated factors which are expected, but it was not there in the underlying data, and that made it much more visible. So that's where the main benefits of combining interactivity with explainability comes in. And I would say that was something probably missing in the prior work.
Okay, thank you. I think I have time for one more question. So you define interactive explainability as the unification of explainability and interactivity, basically, in your dissertation. In practice, what are the key trade-offs between, let's say, transparency and usability, and how one with the design choices can navigate those tensions?
Okay. So in terms of the practical trade-off, I would say it's quite situational. In some cases, more transparency is required. I would go for maybe more high-stake domains where transparency becomes important, and especially when we talk about domain experts, they would really want to know what's going into the model for getting certain predictions. So that's where I think transparency and even the overall relevance of the outcome is important. But in terms of a non-expert or a regular user who might not really think too much about what is going into the model or what kind of algorithms are being used, for them I think it's more important towards the usability part, where they should have the capability of knowing how to get a desired outcome, especially in given a certain task. So that's where it's more outcome focused, I would say, and that's the trade-off. So it depends on the type of the users who will be using them. For some, transparency and knowing how the model is working is more important, but for some, coming up with more relevant outcome is more important. So that's where I would try to go for it.
Thank you very much.
Thank you for the questions.
Thank you, Professor Turkaman.
Yes, thank you, Aditya, for this very clear and enjoyable presentation. So I have a number of questions. So my first question is regarding chapter 3, where you speak about where you use these LLM, these large language model agents, and of course they make mistakes. And I saw you showed some mistakes of AI systems in general, prediction models, but these generative agents, they generate dialogues and responses to dialogues. Sometimes they hallucinate. And so in your literature study, did you encounter theories explaining these hallucinations? And given the underlying architectures, maybe you want to go deeper in it in your future work. But my question is actually, could these theories provide insights into the settings in which hallucinations occur? And would it make sense to take such findings into account when providing explanations to users?
Very, very important questions on hallucinations. And for the broader audience, when we talk about such larger generative AI models which can be used for various type of tasks, one common problem that has been observed is hallucination, or creating fabricated information which doesn't exist at all but can be misleading sometimes. And becomes a problem especially when people start over-relying on the outcome without any kind of verification. So in my case, indeed that was an issue, but when we designed the system, one thing we found that the users wanted to validate with the information they know it's true. And that's where validating with the job description document, their exact resume, information was important. So when we talked about active job seekers, they actually wanted to see what kind of skills were not present in their resume, which was actually mentioned in their job description document. So in such cases, like from a broader perspective, in such cases it is important to validate the information with a known source of truth. Like in this case, it was a job description document and the resume. But in certain other cases, where let's say the users wanted to find out information about the company, it could be the actual company's website. And it might not be even something like Wikipedia. In our case, it was a web search which was done. But for more practical cases, I would say going into the company's information and then presenting certain questions which the users are answering from such validated sources was important. So down is called as the retrieval augmented generation, which is a process of finding information from a formed knowledge base, where we can form that knowledge base using information which is coming from a validated source, and that's where we can find reference to certain information which users can actually validate the responses with. So indeed, that's an important thing that we did. In our case, it was restricted only to the resume as well as the job description, but there was a similar research which was done by one of our colleagues, where we also tried to look into more established sources of information in case of healthcare, like information coming from WHO or CDC, which are the sources which are publicly available. But then whenever more high-stake communication comes into picture, then validating from these established sources of information became very important. So I would say in order to cross-validate such issues like hallucination, referencing the original source of information which is really trustworthy becomes an important factor. And steps like retrieval augmented generation is definitely a good step to go for.
Yes, I agree. So I have another question on your chapter on explanatory debiasing. You correctly propose the role of domain experts when you perform data augmentation for mitigating this representation bias. So you mentioned that models overfit on training data, especially when the training data are very small size. My question is data augmentation sufficient to solve this problem? As augmentation usually builds variations of the patterns through transformations of the data, some noise injections, Gaussian noise, for instance. So this technique might not recover complete new patterns in your data, which you might not have seen in your training data. Could you comment on it? Whether in your domains it was a problem, or maybe in other domains where your techniques could be applied?
Right. That's again a very important question. So when we are talking about data augmentation, something that we observe that the augmentation algorithms tend to replicate biases which are there in the training data. It could be certain strong dominating patterns which are there in the training data, or in some cases the methods which are used, they introduce some randomness in terms of coming up with data points which are not exact duplicates of the underlying training data. And sometimes this randomness is not aligned with real world observation. So something that was useful in our case was the validation by domain experts, where they were able to identify that these two factors are important, but they don't truly go with each other, especially the values that was generated in the synthetic data. They said that maybe the direction in which the values are being shown, it's not actually good. It should be the other way around. So that's where they were able to refine the validated data. So in short, I would say there is an importance of domain knowledge, like coming into the process, and any kind of inspection by domain experts can make the process of augmentation more, or I would say better aligned with the real world observation. So that's important. So in these cases, augmentation is not just sufficient, but it needs to be inspected by domain experts, which can actually make it aligned with real world observation. Now there is one potential, I think that's rightly pointed out. Maybe there are certain cases when new patterns need to be discovered in the training data, especially in those cases, identifying those new patterns can be difficult. I would say maybe it needs additional experimentation in terms of coming up with potential approaches or rather potential patterns that can be introduced, and then using that as a way to validate maybe inspect using domain experts. so that whether that pattern is really useful in a practical use case. So I would say that in that case, the system needs to be expanded. It's not just about the pattern which is there in the current training data, but if there are any potentials, instead of discarding it, because in most of the cases maybe data scientists would just discard something which is not commonly seen. So instead of bluntly discarding it, maybe inspecting, or having an inspection process where domain experts can actually give some reasoning of why this kind of pattern would be discarded, can create a broader knowledge base and use that as a way to maybe create a graph-like structure where that knowledge can be embedded and then used for other use cases. That's an approach I see it at this stage.
Yes, I think it's a very good idea to engage these domain experts, but you put quite some responsibility on their shoulders. So you have to find excellent ones.
That's always a practical constraint. I truly agree.
Maybe I have a last question, which is a much broader question that goes beyond your PhD. Although it relates a bit to your chapter on interactive explainability through conversational agents. So there are some theories of linguistic anthropology and sociolinguistics that claim that the natural language that people use in their interactions with technology, for instance, actually change. The language changes because of the technological changes. These are quite important theories in this field. And so the basic idea is that technological innovations reshape the way people interact, and that those interactional shifts feed back into the changes in natural language. So what is your view on it? And did you notice that users change their language patterns when interacting with machines? And if you want to design user studies, is this something you would take into account? Would it be worth investigating?
Yes, I would say that's an excellent question. And probably I can relate this to an issue of data drift in conventional machine learning systems, especially in certain real-time prediction systems when there is a incoming data which is coming in huge volume. It is always believed that there could be a natural drift in the data. One example could be like, let's say if I'm doing some financial forecast, any data which has been collected before the COVID time might be very different from how users are generating some kind of financial data after the COVID time. So there could be a natural drift to it. So in order to address that, I think the first step I would try to do is detect it. I haven't actually come across this term of data drift detection for natural language. It's a very interesting concept. So I think that's important, and probably measuring that as part of maybe an observability layer would be important, which kind of continuously monitors whether there is any kind of natural language drift in the training data versus the data that users are actually using it. If there is a strong drift, I would definitely believe in terms of refining or retraining the model on the newer data so that it is more suited to the current contextual information. And yes, indeed, this is I think these are certain qualities which we should be measuring even as part of the user studies. Because right now the focus only goes towards hallucination, the context relevance, the overall faithfulness, but it even goes beyond that. And that's where I think these issues are quite important to track. And yes, if there is such issue, I think the way to go forward would be to retrain and make it more specialized for the current set of users.
Okay, thank you for the answers.
Thank you very much for your questions.
Thank you, Aditya, for the very nice presentation. It was nice to be part of the journey. I could follow it from the beginning, and with the intermediate presentation, I always very much enjoyed our interaction, so I will hope you will live up to the expectations I have right now. I want to continue a little bit on the discussion you already had with previous members of the examination board. And the first one is connected to the using large language models as an explainer. Because somehow it's quite different than other explanation techniques we have been using. So would you say that the output of a large language model itself is an explanation? Do we need another explanation to explain the explanation of the large language model? And how would a data-centric explanation, a model explanation, a what-if explanation, a counterfactual explanation look like in that case?
All right, that's a very interesting question. I would say that solely relying on LLMs for generating explanations or even explanations for an explanation can be a bit difficult in certain use cases. So I wouldn't directly rely on LLMs for generating such explanations directly. But what I would do is use the LLMs to parse the explanations in a better way so that it's more user-friendly. So for example, in certain cases, counterfactual generation algorithms, they produce a lot of numerical values. And in some cases, it's not just one value, it's a set of values. And that requires, again, some post-processing to make it more confined and identify the best one which could be most useful. So that's where I would probably leverage an LLM to kind of synthesize that information and present it in a more user-friendly way, so that it's not just one statement which says that this is the reasoning for the prediction, but if user tries to cross-question it, the model would be able to identify that and give a much more in-depth information. And that's where I see that benefit, the benefit of having or engaging with the model in a more dialogue way and not just as a one-off explanations. So I would predominantly use such systems to establish that cross communication between the users and have that back and forth conversation with them.
Yeah, so you kind of use it more as a translation device between a more traditional explanation technique. But then at the same time, are you not containing the large language model too strictly? Because it does have a lot of domain knowledge which you could harvest inside the explanation. And how will you contain it? How will you know that it's just acting as a translation device, or actually it's putting in some of its own domain knowledge, or it's starting to hallucinate and putting in some wrong information? So how will you contain
Yes.
that?
Yes, that's indeed a problem that needs to be addressed. So in these cases, I generally like going for something like a retrieval augmented generation, which relies on the knowledge base, which are kind of confined to validated source of information, where the LLM in most cases do not rely on its broader knowledge for generating information, but rather using the the existing knowledge base to produce information which is easily consumable to the users. So that's a path that I have explored. And that's where I see the overall challenges in restricting the LLM from hallucinating on the broader knowledge can be addressed to a great extent. But in some cases, it requires additional guardrails, the way I call it. It's like making the model, instead of go wild in terms of its thinking and imagination, making it focus towards a certain area so that the outcome that comes out of it, it's more focused and more directed. And that's a benefit that I have seen. In some cases, I have also seen researchers going for additional fine-tuning approaches, which fine-tunes entirely on a new set of data, which could be a viable approach. And apart from that, I have seen some additional post-processing techniques, which tries to validate if there are some potential problems, and if there are problems, they just discard the output. But maybe it's more work and it requires more experimental approach. So my personal favorite is going towards the retrieval augmented generation approach, which in most cases gives more confined set of information.
Really interesting. And in our project, we also look if we can use explanation to improve the large language model. So maybe we can close somewhere the loop that we are in. Another thing we have discussed before is like the use of domain experts. It's hard because these people, of course, are very scarce, and you have to find them, they have to be willing to participate. But then on the same time, I do think that you really put a lot of trust in domain experts. Although domain experts can also be wrong. They have been educated, they have their own experiences, so they could introduce biases themselves. And then you provide them with interactive options that can help them to steer the model. So will they not just be steering the model towards their mental model? And are you then not missing a crucial opportunity where the machine learning model could help them to challenge their mental model to maybe help get them rid of existing biases, to gain knowledge, etc. So is there not a danger of trusting too much in the domain experts?
Yes, definitely. And even in some of our studies, especially I think in the last one, we have observed that some of the domain experts actually made the model performance a little bit worse than what it was. So when we try to inspect in more details, we found out that it's the level of the domain knowledge even they have. Like not all domain experts will have equal level of domain knowledge. Some might be a little more knowledgeable. In some cases, some might be a little less knowledgeable. So one thing which worked out, or I wouldn't say worked out because we need to try it out maybe in more depth, but something that can work out is more like a group effort instead of an individual effort. And this process is very similar to maybe a peer review system in case of academic research papers or even code review. Like even for open source contributions, when someone makes any changes, it directly is not integrated with the main source code. It goes through a series of review process, and that's where there's a discussion part of it that also comes in. So I think that process is very important, where it's not just an individual steering which is happening, but more like a group steering, where a group consensus can actually be formed. So individual, I think, biases or individual limitations in their own mental models can actually be mitigated using such group consensus. And that's where the broader community of experts can actually steer the model in the direction where they want it to be. So I would say that's more practical.
Yeah, I think that's a very promising direction. It also connects to the Delphi consensus studies that they do a lot in the medical domain. So that would be really nice. Now, you have been doing very impressive user studies with a lot of users in different applications, etc. But it's always easy to criticize, and I'm using this opportunity. Why have you not been tackling longitudinal studies? And what have you missed by mainly focusing on these user studies that go for a shorter duration? And what would change if we do it in a more longitudinal way?
Right. I think in some cases, measuring human perspective through one-off studies is difficult, especially when we talk about trust, because that's a more complex concept, and that's where measuring through one-off studies is often difficult, because it really requires that amount of engagement with the system for a prolonged period of time to truly understand the nitty-gritties of it. So that's where the findings of my own studies is more like an indication, like what can really contribute towards it. But to have more conclusive evidence or more stronger evidence, I think longitudinal studies would be the way to go for it. But having said that, conducting longitudinal studies has its own challenges. Conducting the same study for a period of time with the same set of users, with the same set of, I would say, involvement and excitement is something which is difficult. Maybe in medical cases, it is more common because, then in certain cases when we are testing drug efficacy and everything, it's really important and that needs to be done. So that's where I think the way they go for is maybe offering higher reward to the participants as a way to engage them actively in the process. In our own cases, it's difficult in terms of such practical constraints that we often need to juggle with to conduct the studies. But yeah, if we don't have such practical constraints, especially for measuring certain complicated user perspective, I would say going for longitudinal studies is helpful.
And of course, it's very nice of you that you leave some challenges for the future PhD students as well. Thank you so much.
Thank you so much for the questions.
Thank you very much. And then we come to the supervisors first, co-supervisor.
Thanks, Aditya. A very nice presentation. I was going to ask yet another questions about LLMs, but I think that has been explored to some depth now. So I'm going to change tack a little bit. The main point of interactive machine learning, and thus I assume for your work, is to improve model performance through the input of domain experts and users, so exploiting the knowledge that they have to integrate back into the model. So that leads me to a question: when should we do that? Right? When should we offer systems such as yours? Is there a particular point in the development process that we should target them at, or is there some other way of thinking about that?
Okay. I would say that especially in high-stake domains, it's important. The main reason is their domain knowledge creates a difference, first of all, in that case. And considering the practical challenge of involving them, it becomes more important because it's a more impactful situation in which I think they would step forward towards helping the system. So especially for high-stake domains, I would try to go for involving domain experts. Now the question comes in, do we do it for all high-stake domains or do we do it for some? So maybe in some cases where gathering good quality data and sufficient amount of data is difficult, that's where I would try to prefer as a trade-off going for them. And in situations where the use case is critical as well as gaining high quality data is important, that's where I would try to involve them right from the beginning. Because in some cases it has also been observed that if domain experts are involved, that's at a much lower point in the machine learning cycle. Like once the predictions are coming in, then they try to check whether it's a good prediction or a bad one. But they should be involved even at the beginning, because that would prevent the model from actually making the mistakes which it has been doing. So I think when we talk about the long-term perspective, if they are involved in such high-stake domains where getting good quality data is difficult and finding how models, or especially more complicated models, how they would behave is difficult, involving them right at the beginning can save a lot eventually and make systems which are better aligned, rather than using their domain knowledge to patch up issues which the model is making towards a later point of time. So that's where I would try to prioritize.
Finally,
thank you, Aditya, for the nice presentation. Most of my questions were also asked already. But I am going to follow up with one LLM-related question. So you commented on the fact that you would use LLMs to make the explanations more user-friendly, etc. But can you also explain in a bit more detail how people are now trying to explain LLMs? So we know that these standard methods don't work very well with LLMs. What are then the approaches that people are currently exploring to explain LLMs?
Interesting question. I might not have the best answer, but let me try towards answering it. I think the main reason why explainability for LLM models directly becomes difficult is because LLMs themselves are so complicated that there are multiple places where they can make mistakes. It's not just one. And that's where issues like hallucination even started coming in. But there are even more issues that come, that becomes more popular. Let's say, for example, in our studies, one thing which we have observed is more like an amnestic syndrome of the model. Like in some cases, the main contextual information which it was supposed to consider for making a prediction, it missed that. It did not forget it completely, but it somehow missed that. But then when some of the users nudged them that this is an information that is already given, why did you miss that? Then it was able to identify. So that means it is not just giving explanation from a certain information, but it's there in the memory, but somehow the importance of it is less. So I think because of that, there are additional type of problems which can occur. So especially in case of LLM, the main challenge comes in how the contextual information is getting engineered into it. Like that's the base using which the explanations can even be generated. So more work towards explaining the contextual engineering process, I think, is something which can, create bigger paths of coming up with better explanations, maybe. But that's an area where I think a lot of the issues are coming from. So it's not just towards the end, because hallucination is again something that happens towards the end when the model kind of tries to choose between different words to give a particular prediction. And in case of if there is a broader vocabulary, then it also becomes difficult for the model to really prioritize which words that it should pick up. And that's where it kind of generates facts which are not there. So I would say it's not towards the end, but there are intermediate layers within the LLM, within the typical transformer network of the LLM, which are also directly responsible towards creating outcomes which are not reliable. So that's where looking into such memory issues, looking into the way the contextual information is being processed and engineered, I think becomes really critical. And explanation process may not be directly for end users, but there could be an intermediary process which can even help developers to understand whether there are potential drawbacks of that existing setup, and whether that can create outcomes which are unreliable for the end users.
Okay, thanks to the members of the examination board for their questions. As I said in the beginning of this session, it is a public event and there is time for questions and comments, not only by the Board of Examiners, but also by the audience. So now I'm at the point of inviting you if to ask a question or give a comment. Yes, I've seen there's one in the chat. A person who left 24 minutes after the start of your presentation, but I also suggest to take the question of this professor, he or she, I don't know, maybe you know.
He's our colleague, former colleague.
Okay, so for the conversational approach, your second study, were you able to position your approach in comparison to some popular prompting techniques like React, which claims to help transparency and trust?
Yes. So just for the broader audience, when we are trying to design large language models, there are various techniques which are applied to generate better outcomes. And there is a particular framework which is called as REACT, which means reasoning and acting, has been used to create outcomes which are better in terms of the reasoning part. Now, React prompting is something which is useful when we are trying to explain a process step by step, in terms of even understanding if the model is making mistake in the intermediate steps. But in our case, we did start experimenting with React, but since it was a use case where we had to produce the outcome in a real-time situation, React prompting actually made the outcomes much slower. So it's like after typing a question, the users had to wait for 5 minutes even to get the answer. So especially in case of a real-time chatbot, that was not the best way to go for. So we did not go for React eventually because of that limitation. And another reason why React was slower because we had multiple agents where the communication exchange was happening. So if each sub-agent is thinking too much, it was getting stuck into a typical process of analysis paralysis. Like when you think too much, you kind of get into a paralyzed or paralysis state where you do not take that action which is requested. So in order to prevent that, we did not go with React. Instead of that, we used various guidelines which kind of gave the chatbot the exact nature of the outcome that we are looking for. The guidelines we initially formulated from the user requirement study that we did, the exploratory study, which helped us to gain the user requirement. And that's where we defined the individual roles and the behavior of the agent. And we used that as a way to formulate the guidelines, the prompting guidelines to steer the behavior of the model. So yeah, the short answer is we tried with it, but it did not work because of the real-time nature of our work.
Okay, thank you. Maybe I'm moving on to thin ice, but I'm asking attendance online if there is, if they have a question, they can also put it in the chat or open their mic, identify themselves. And,
I want to ask a question.
you have a question? Yeah. Okay.
Yeah, I have a question. Thank you for your presentation, Aditya. And this question is inspired by the Professor Robert's questions called the friendly large language model. So currently, we sometimes want to use a large language model to make sure some system too complex cannot be explainable for the non-expert users. So we use the large language model to convert something to some natural language output. But sometimes we feel that the large model output is too complex, too long, and we do not think that was user-friendly.
Okay.
So do you think whether we have any way or any method can convert the large model output more user-friendly?
Okay, good question. Yes, in some cases, the large language models are trained in a very generic way. That's where they are meant to produce outcomes which are, which are more useful for a generic set of tasks. And as a result, they might give outcome, in a larger volume, which might be too much in certain use cases. So that's where there are several strategies which are, experimented. The first strategy, which would probably I would try to try out, is on prompt engineering, which is the easiest, which doesn't require the model to learn new things or unlearn the existing thing, relearn new things, but rather it tries to change the behavior of the model itself. So that's where prompting techniques are the easiest and the cheapest way towards getting outcomes which are more suited for a specific set of users. In some cases, prompting techniques might not be sufficient, and that's where fine-tuning comes in. And especially one fine-tuning technique which I remember OpenAI trying for fine-tune on GPT 3.5. That's called as the reinforcement learning with human feedback. So that's a more complicated process, but it requires you to have an initial set of supervised training data where you have a kind of initial set of input-output queries where you have the input questions and the corresponding output. And then once you formulate that data, you form a reward model. The reward model is done in such a way that when the model is producing multiple output, you kind of try to give some kind of ranking that this kind of output format is better than the other ones, and then you kind of generate a set of rankings. And when the rankings are generated, you use that as a reward model to fine-tune the entire process through a typical reinforcement learning use case. In case of ChatGPT, I remember they use something like proximal policy optimization. Sounds very fancy, but it's like a reinforcement learning algorithm which tries to come up with best set of steps which are required to achieve a particular outcome. In this case, the best changes which should be there in the individual input to get a final output. So that's where similar kind of algorithms can be tried, and that could create an outcome which is more fine-tuned for that specific target user group. So that's a broader, more complicated process, but in some cases, if prompt engineering is not working, maybe a reinforcement learning with human feedback would be the way to go forward.
Okay, thank you. So what happens now is that the board of examiners will withdraw for a few minutes. We come back later to the outcome of this defense.
I hope it was not too boring.
Isn't it? Great job.
Okay. Yeah, it was a bit lengthy, and I know the time was well, like after lunch.
Also very impressive for you answered all the questions.
Yeah.
Thank you.
You've done this before,
But
and
everything is going to be cool.
I had zero practice by the way.
Well done.
Thank you.
Do you remember last time the Maxwell
তো প্রচুর কোয়েশ্চেন আনসার্সের পর এখন জুরি মেম্বার্সরা চলে গেছেন নিজেদের মধ্যে ডেলিবারেশন করার জন্য বিফোর অ্যাওয়ার্ডিং হিম উইথ দ্য ডিগ্রি। তো এখন সেই জন্য প্রায় 15 to 20 মিনিটসের মতো একটা ওয়েটিং ছিল এবং সবাই তার জন্য ওয়েট করছিল।
Ladies and gentlemen, I have the honor to inform you of the outcome of the deliberations of the examination committee appointed for the examination for the degree of Doctor of Engineering Science. Aditya Bhattacharya has submitted a thesis to the faculty entitled Beyond Explanations, Designing Interactive Explainable AI Systems for End Users, and this in order to obtain the degree of Doctor of Engineering Science. He has defended this thesis in a public session before the examination committee. Dear Aditya, the examination board has determined that you have met all the requirements prescribed by law and by the university regulations for the doctoral examination. By obtaining the doctoral degree, you commit to act in accordance with the basic principles of research integrity as described in the All European Academy's European Code of Conduct. And these principles are reliability, honesty, respect, and accountability. Therefore, and on behalf of the Director of KU Leuven, I confer upon you the degree of Doctor of Engineering Science in the domain of computer science, summa cum laude, with the congratulations of the Board of Examiners. In accordance with legal provisions, I also have to make this announcement in Dutch. Bijgevolg en in naam van de rector van KU Leuven verleen ik u de graad van dokter in de ingenieurswetenschappen in het domein van de computerwetenschappen met de grootste onderscheiding en de gelukwensen van de examencommissie. Congratulations, and the session is closed. But we can... The secretary will hand over, it's a provisional certificate of the diploma.
PhD with distinction পেয়েছে
Aditya
কোন
has to
সময়
sign for it.
কোন লটেতে বললো তার মানে ডিস্টিংশন
So, as I said, the official session, official ceremony is closed now, but I invite Professor Robert, the corresponding supervisor, and she will say a few words to you.
ये रिसेप्शन है तो क्या की बोलबे तो
It's a great honor for me to say a few words about Aditya. Aditya has been an outstanding PhD student from the start. He showed incredible drive and dedication. He worked very hard, and the results are impressive. You have 2 Chi papers, one with an outstanding and honorable mention award. Very few PhD students achieve this level of recognition, and it shows the quality and the impact of your work, so congratulations. What really stands out about Aditya is his determination. Once he believes in something, he follows it through with great persistence. In my data visualization course, for instance, I teach about the use of color and the fact that if you use red color, that you should do it with care, because it does have a negative connotation. Yet, if you browse through Aditya's PhD text today, you will see many parts in red. It may seem like a small detail, but it captures his character. Aditya is determined, confident in his choices, and not easily persuaded. This determination, together with his talent and hard work, has led to truly excellent results. Aditya, we are very proud of what you've achieved, and I'm sure that your persistence and creativity will take you far. On a personal note, I also want to thank you for your dedication, for the high standards you set, and for the inspiration you brought to our team. It really has been a real privilege to supervise you. I also want to take the opportunity to thank Professor Simone Stump. She stepped in, co-supervised the thesis, and it's also thanks to her real dedication that we managed to achieve these great results. But so, congratulations, Aditya. I hope you enjoy this well-deserved moment.
You want to say a few words? Or? But maybe can you make sure that Professor Tontaman is
ঠিক আছে উঠছে তো
তোমাকে খুব প্রাউড লাগছে
So much. To be honest, I don't have a formal speech ready, but I just wanted to take this moment to thank every one of you for being here. I think time is the most valuable thing anyone can offer. So I really want to take this moment to thank all of you who have been here, both online as well as in person. But at the same time, I think like all journeys, we need supporters to make anything successful. And I have been blessed with not just one, but many. Starting with my supervisor, Professor Katrine Werber. thank you, first of all, for giving me the opportunity to do this PhD. I think this journey wouldn't have happened at all if you have not shown that trust and faith. So thank you so much for giving this opportunity. Thank you for being here. I'm someone, I ask a lot of questions, and I think I have asked too many to you too. But every single time you have taken each of my questions with patience, and you have answered and shown the support whenever I have needed. So thank you so much. And I think the main credit for the success of the journey also goes to you. And along with that, I would like to take this moment to thank my co-supervisor, Professor Simons too. First of all, 2 Chi papers. I think back-to-back Chi papers, it wasn't easy, and it wouldn't have been accepted without your active support. I learned a lot from all the research protocols and the studies that we followed. So it was a big learning opportunity for me. And every single time you have stepped up, you have shown me this is how it's done, this is how we can do it better. So that was really, really helpful. So I'm really glad that you have joined this journey as a co-supervisor, and I'm quite grateful to you. I'm also grateful to all of my jury members. Right from the beginning, Professor Tinadilak, you have guided me with the different strategies, especially in certain cases when I thought of doing too much. Then you showed me that it's a trade-off that we need to do. We need to go in depth, or we can choose different domains, and you have shown me that the importance of going depth is also there. So you have given me the guidance, especially in the initial years when in the initial years you have a lot of energy, and sometimes it becomes important to show that direction so that your energy goes in a focused way. So you have played that part, and I'm quite grateful to you. I'm grateful to my other accessor, Adalberto Simeon, Professor Adalberto Simeon. Unfortunately, he couldn't have joined us. He's traveling, but he has also given me the great feedback right from the initial years, and because of which I think we could have the final set of journey in a much better way. Thanks for joining you as well, Professor Simons. Especially in the last mile, I think the support is very important, and that's where you have given the feedback, you have given the suggestions, the guidelines for improving it. And that was really helpful, especially the questions that you have given me. It's not just important from a discussion perspective, but it's also thought-provoking, especially for me, like when I'm thinking about my next steps. That's where it's also important to think about areas which can really make an impact, and that's where you have helped a lot. So thank you so much. And Professor Joris de Scooters, thank you again. You have been the most amazing chair I could have ever imagined for. And I'm quite serious, because I have seen many chairs playing an active role, but you have been quite instrumental, not only in making sure that everything goes on in time, but you have also been supportive from day one. Especially, I did not have to run behind you for getting anything. You have been very active. You have been responding whenever I had a question, and you have given that support. So thank you so much, and I couldn't have expected a better chair.
Online
and then comes my team over here, all the members of the document, starting with Robin. I still remember the very first day when I was entering this building. Robin was the person whom I called, and it's not just about that. It's also about the support which Robin provides. And I truly believe that you are the backbone of Augment. So whenever there are any question, any new members comes in, you have been extremely supportive, helpful. You have in fact shortlisted me for this particular position. So I think this journey wouldn't have also happened if you have missed that time. But you have played that active part, and I'm truly grateful for you. I have all my other members over here. I have Vijay, who have been extremely we have been talking about a lot of ideas, so we have also focused on many things, which is quite helpful. And especially from your perspective, when you're joining this journey for the first time, I believe that your support was also quite helpful, especially in some of the later studies that I have done. So thank you for that. I have Ivania. I have been working with Ivania for almost, I think, 3.5, 4 years now. So that was really helpful. We have went on to many our team events that we often go for. Then we had worked on various research activities, so that was really helpful. So I have Roberta with us. Again, we have not got the opportunity to work in depth, but right from the start, you have been there, and you have shown your time towards me today. And then we have Anna. Oh, I missed Professor Elma. So sorry. Sorry, I'll come back to you, Anna. But first, I would need to.
I thought so.
I would need to talk about Professor Elma Torkaman first of all. Sorry I missed you. I was looking into the people over here, so I kind of missed looking back and in front. But yeah, I just wanted to thank you as well for for being the external, especially with asking the questions, especially when I tried to improve my thesis, your feedback was extremely helpful. You were very detailed about all the different chapters, especially even like in certain cases when I missed few things about the reference, you were also like very detailed about going into it and help me with suggestions which can really help me. So I'm quite thankful for you, and believe me, I couldn't have expected a better external as well. So you have been quite supportive, and I wish we get to even work someday in future. So thank you so much. And I believe there are no other members online. Yes. But anyways, I just wanted to thank everyone who joined online as well. I was able to reach out to my former colleagues, and they were all quite helpful in terms of, especially when I started the initial set of journeys, I got a lot of feedback which helped me to kind of formulate the journey in a much better way. So I'm quite grateful that some of them were also able to join today. But then coming back to my team over here, I have Anna, I have Reese, I have Gregor. All of them joined very recently, but it feels like we have been working for long, especially for the fun times that we had. I learned a new sports from you. We played all together, and Gregor, you have been always, like giving me feedback for the papers that I have submitted. So thank you so much. And today Soha helped a lot, especially with the logistics, putting up all the banners and everything. So that's the support that kind of made me very comfortable and very, I would say, free today in terms of giving the presentation. But yeah, I have John as well. Again, you have joined recently, but it feels like we have been working for long, and you have been quite an important part, especially talking about the last few things that we were doing. So thank you so much. Maxwell made my PhD journey much easier, especially in the last few days, because when I was writing my thesis, I actually had to refer to the work that he has done. So it made it much easier, especially with the presentations, with the format of the PhD. So it was quite helpful, and believe me, it saved me several hours of work. So you have made my final milestone much easier than it would have been. So thank you for doing that. And I have Yu-chan as well. So Yu-chan, thank you for joining in. I have known Yu-chan, I think almost 3.5 years now. We have been closely discussing about some of the works on the data-centric explanations. So thank you for being here. And again, if we meet again for discussions on the same, I'll be very happy to discuss the same. Now, I would like to take this opportunity to thank my family. I have my aunt all the way from the UK at this age as a representative for everyone. So my parents initially wanted to join in, but my father had an accident, and because of which they were not able to travel. He's recovering now, but because of the medical issues, he couldn't make it here. And that's why my aunt kind of came as a representative of everyone back then. But I'm fortunate to have my parents, especially PhD is not something that we do only for a certain set of years, but it's also a reflection of the life that was before that. And that's where I learned the best lessons of life from both of my parents. And
last but not least.
No, I'll come to that. Don't worry. But yeah, I mean, I just wanted to take this moment to thank for everything that they have done. And typically in our Indian culture, we have a very big family. So that's where it's not just the parents, but also the other family members who come in. First of all, I'm blessed with just not one set of parents, but also my parents-in-law, who are always cheerful and has been giving me the encouragement required for any ambitious stuff that I do. So they have been there. I am also blessed with a lovely sister who have been my advocate. Whenever I do anything mischievous, it's my sister who always gets my back. So she has been there. And I'm also lucky to get a sister-in-law, my wife's sister. She has also been another advocate of mine. So I always have these left and right hand with me whenever I go. So that's always good and easy for me. But at the same time, I'm blessed with many uncles, many aunts, many cousins who have been there for different stages of life. But this PhD journey, I would say a big chunk of the credit actually goes to my wife directly. The main reason is when I completed my bachelor's and even I had gathered the courage to do a master's. But to be honest, after that, I felt PhD would have been extremely difficult and extremely dreadful. So I kind of felt that maybe it's not something that I can do, and I did not have the courage to do that. But it was actually my wife who was the North Star of this journey, who has actually shown the way. And she told me that it's okay, PhD, you can still do it. And I took the leap of faith because of her. But I'm glad that I did. I learned a lot from the way, and the journey is, I would say, much pleasant and became much easier with all your support. So thank you for being there, and thank you for all the things that you have done so far, especially for this journey. So with this, I would like to conclude my little speech. It was a bit underprepared, but I hope I kind of spoke about it, and it's something which I've said from my heart, to be honest, and not just from my brain or even ChatGPT, as my aunt was always telling. But thank you for being there, and with this, I would like to conclude, and we have a little reception after this, so I warmly welcome all of you to join me and share the joy that we have today. So thank you so much. Okay, so Professor Helma, we missed today. You could have joined us as well.
I'm very sorry I couldn't join in person. I hope you celebrate and lots of congratulations.
Okay, thank you so much. Thank you so much. Bye.
Bye.
Oh, we'll take a picture.
তো আদিত্য গট হিজ পিএইচডি উইথ ডিস্টিংশন। এটা খুবই রেয়ার কেস, কারণ খুব ভালো থিসিস না হলে পিএইচডি উইথ ডিস্টিংশন কিন্তু পাওয়া যায় না। আর এত ভালো নিউজ সেলিব্রেট করার জন্য আমাদের তরফ থেকে একটি ছোটোখাটো রিসেপশনও রাখা হয়েছিল। আমরা খুব কনসিয়াসলি ইন্ডিয়ান ফুড রেখেছিলাম, যাতে যারা বিদেশি আছেন তারাও যাতে আমাদের দেশের এক টুকরো স্বাদ পান। যাকগে, আজকের দিনটা তো খুবই ভালো গেল এবং প্রচণ্ড হেক্টিকও ছিল। তাই আজকের ব্লগটা এখানেই শেষ করছি, এবং অফকোর্স ভালো লাগলে ডোন্ট ফরগেট টু সাবস্ক্রাইব টু আওয়ার চ্যানেল দ্য সুটকেস কাপল। দেখা হবে পরের ব্লগে।